Alright, so we're on Year 12 Mixed Exercise 16, question 10. Again, we're looking at kinematics, and we're told that a pair of cameras records the time that it takes a car on a motorway to travel a distance of 2,000 meters. A car passes the first camera while traveling at 32 meters a second. The car continues at this speed for 12.5 seconds and then decelerates uniformly until it passes the second camera when its speed has decreased to 18 meters per second. We're asked for the distance in the first 12.5 seconds. We're asked for the time during which it's decelerating. We're asked for a speed time graph for the 2,000 meter stretch, and we're asked for the average speed during it. And this is a real question from AQA in 2011. I think it's a very good question. It brings together lots of challenging things. Although section C asks for the sketching of the graph, I think that's probably the first thing to do, just to be able to translate what the question asks into something we can actually use. So we're told it travels a distance of 2,000 meters. It passes the first camera at 32 meters a second, continues at that speed for 12.5 seconds, then decelerates uniformly until it's 18. So our speed time graph is going to look something like this. Time across the bottom, of course, in seconds, and speed in meters per second. We start then at 32 meters a second up here, and it stays at 32 until I get to about, well, not exactly 12.5 seconds. It then decelerates uniformly, which means I have a nice straight line, until I get to, I think it was 18 meters a second. There we are. So at 18 meters a second, I get there, and that's at some other time later on. And what I know is that the distance traveled, which of course is the area under this graph, is 2,000 meters. So we'll use all that information in a second. Calculate the distance traveled by the car in the first 12.5 seconds. Well, that's just this area under here. So for part A, I say simply that distance is speed times time, and that comes simply from the fact I have no acceleration. We're told it continues at a constant speed, which is 32 meters a second times 12.5 seconds, which comes to, I can find my calculator, 32 times 12.5 gives me 400 meters. So 400 meters is how far it's traveling while it's not decelerating at all. I'm then asked to find the time for which the car is decelerating, which is, let's be careful here. If I call this some time, let's call that tau, then the time for which it is decelerating is in fact this time here, tau minus 12.5. So let's be careful. Tau is the actual time from 0. So when I calculate that in a second, we'll know it's there. The time for deceleration, of course, is there. Well, how would I do this? I can, of course, use my Suvat equations and stuff, but actually the graph here is very helpful, because what I know is that the total distance there is 2,000 meters. So I know that this area here, if I shade this in, must be worth whatever this bit wasn't. So I know that this bit was worth 400, which means this bit must be worth 1,600. So the area under the graph between 12.5 seconds and tau is equal to 1,600 meters, but it's also equal, remembering it's a trapezium, it's the two parallel sides, the average of those, so that's 32 plus 18 over 2, and I'm multiplying that by the distance, which is tau minus 12.5. Indeed, for clarity, let's make this even simpler. Let's say that that distance is, that time, for example, is some time b. So I can say that a bit simpler, perhaps, as 32 plus 18 over 2. That's the average of two parallel sides times the height here, which is b. And I can solve for b without too much trouble here. 32 plus 18 is going to be 4250, so that becomes 25 times b. So b is simply 1600 over 25. Sorry, I've shot before. 1600 over 25 is 64. So it's going to be 64 seconds for which I am decelerating. That's part B. Part C then is looking at the speed time graph. I've already done that, and I can put my numbers in. I can say that this time then isn't going to be 12 and a half. Sorry, it isn't going to be 64. It's going to be 64 plus 12 and a half. So that's going to be 76.5 seconds. So that's part C. And for part D then, find the average speed of the car on this 2,000 meter stretch of motorway. Well, the average speed is going to be the total distance, which we know to be 2,000 meters, over the total time. So I know that's 2,000 meters. I know the total time is 76.5 seconds. And so I can put my numbers in. I get an average speed without too much faff to get 2,000 divided by 76.5 and get 26.14 meters per second. And there we are. And so it's not altogether that bad, but it does bring together the speed time graphs. It brings together the understanding of what's going on. And of course, we can use our Suvat equations, but really they're just an interpretation of the area under the curve measures.